Welcome everyone. My name is Bart Wullems. I'm working as a technical director at Soprasteria Belgium. Before I start, I just want to make some general rules because my Dutch colleagues told me that the Dutch audience needs to be fully controlled, so I try to keep you all under control for the next 45 minutes. In fact, there's only one rule. I don't want to make it too difficult. There's only one rule. I will ask some questions and we do some voting. And if I do voting, I'll ask you to raise your hand in a 100% vertical position. Just like that. What I want to avoid, other situations, I've seen it happen. It can be misunderstood. I don't want this to happen, just in case. Let's try this. Who was listening? First of all, same question was asked in the opening. Who is a developer in the room? Almost everyone. Wow. And some don't want to really show this, that this is the case. Second question. Who is using AI today during his job? Okay. A lot of hands, not everyone anymore. And who asked his boss permission to use AI in the room? Ooh, only a very little. And who had his boss sitting next to him and therefore didn't dare to raise his hand? Okay, I know how to start. We started the keynote this morning with talking about fear. And I really understand where this fear is coming from. Because for the last 1.5 years, I really felt a lot of fear inside. It was really an emotional roller coaster for me. Going from, whoa, what are the cool things that AI can offer, to, oh my God, this is really gonna kill my job. I'm out of work. I'll have to do something else. I have to stay home with my wife. Oh no, I cannot imagine what this means. And you see all these things online, companies announcing that they're gonna fire people because AI is there. You see some tweets on the internet. Sorry, I'm still saying tweets. I don't know if you to say it with X's. I don't know. Saying that our software engineering profession will die. You see the number of job openings for software developers decrease. You see every day a new AI company appear that claims to replace all your developers and telling your IT managers just stop hiring people. And that makes me afraid because maybe I will be out of the job and only the dirty work will be done by me and all the rest will be done by robots. That's not what I'm hoping for. But at the same time, should I be afraid of a system that if you ask to give a random number between 1 and 100, always, or most of the time, returns 42? I don't know why. Should I be afraid of a system that you ask to generate a blue hedgehog will not do any kind of copyright infringement? Should I be afraid of a system that, when you ask it to do some basic math, can be convinced that it's wrong and even agrees with you? I don't know. I don't know. Just in case, what I did is I followed the advice of Mike, who said, okay, just in case, I'll always start every conversation that we have in a very polite way. You never know if it can help or not, we'll see. Now, the thing is, how can we know? How can we know what will be the impact for AI in our jobs? Now, what we cannot do, we cannot look into the future. I can try to predict, but I don't know. But we can look back in the past. We can use a time-traveling machine to go back in the past. And the question, in fact, that we today want to answer is a very simple question. Is GPT a GPT? Meaning, is a generative pre-trained transformer a general-purpose technology? So what is a general-purpose technology? It's a term defined by two economists who have written a book about it. And they said there are a few technologies in the history of mankind that really had a big impact. And these technologies are called a GPT. And they have 4 different characteristics. First, it's recognizable as a single thing. That's an important thing. Second thing, it has a very wide impact at a lot of different places, a lot of different industries. Third thing, you find a lot of different use cases for it. And the fourth thing, it has a big impact, not only directly, but also indirectly. So these are the 4 things that in fact define what a GPT, a general purpose technology, is. And in the history of mankind, there has been 24. Anyone who has an idea about some of the GPTs that appeared over time? You can just shout it out, don't be afraid. Fire. It's not in the list, but it could have been. Steam, indeed, that's one. Electricity is one as well. The wheel, yeah. Internet was also on the list. I think computers, electronics in general, is also on the list. Now, I asked GPT to create an overview. It's not completely correct. So these are, in fact, the 24 technologies that are mentioned on Wikipedia. You can just look at it later. I will not go into all details. But it's, in fact, not only technology itself, but also sometimes a process or a way of working. It's not only a technology itself. Now, coincidentally, while preparing this session, I accidentally arrived on the Dutch Wikipedia website, and there, in fact, the 25th technology was even mentioned. But I don't agree at all. I don't agree at all. Sorry, guys. I edited a Wikipedia page and removed it. It couldn't be. Now, the question, of course, all these GPTs over time, they had quite an impact. And let's have a look at some of the impact that they got. First of all, they all have a big impact on productivity. For example, the Linux steam engine, I don't know who said that, I think Hugo. It improved the productivity with 20%, which already is a big number. The second thing you see is that some jobs disappear. For example, in the 1920s, about 30% of all female in the United States were employed as telephone operators, connecting the calls between different persons. The moment that electronics were introduced and computers were introduced, these jobs disappeared, but most of these people found another job. So you see an impact of GPTs. Typically, some new type of jobs appear, and other ones start to disappear. For example, if you look at the Industrial Revolution, in that time, a new type of job appeared, which was called a knocker-up. A knocker-up was, in fact, someone who made sure that a labor worker was alerted on time, because before he was working on the field, doesn't matter how late he starts, but now he had to be in the company at 7 o'clock, and an alarm clock didn't exist yet, so they had human alarm clocks who walked around with letters, and knockers to knock on the window to say, okay, you have to wake up and you have to be on time. And it took until the 1950s until this job was removed by alarm clocks. So maybe we still have a job as an alarm clock in the future. I don't know. So that's some general information about what a GPT is and what can be the impact. Of course, the question we want to answer today is AI a GPT? And I'm not smart enough to give you the answer myself, but a lot of studies today going on that tries to answer this. And first of all, the studies that are done, they say, okay, we see a very big impact among industries. Some are very large impacted. Call centers, things like that are really impacted by AI. Other ones are less impacted, but about 80% of all the workforce will be impacted. So this means probably we are impacted as well. Another study looked about 1,000 specific professions, and there were only 34 that I've seen that were not impacted. So if you want to be sure that you have a job in the future, maybe you could become a motorcycle mechanic, a pile driver operator. I don't even know what that is. But there are only a limited number of jobs that are not impacted. The ones that are impacted the most are, I think, educators was among them, call center agents, and we software developers are also on that list. So there is an impact. Now, what makes this AI revolution different from previous GPTs is there are a few things that really make it something else. First of all, typically these GPTs are adopted quite slowly. For example, the internet going from DARPANET to being broadly used in the 90s, it took about 30 years. ChatGPT, I think between it was announced and it reached 100 million users, it took 2 months. So you see the speed in which it gets adopted is really, really fast. Second thing, and that's one that makes me most afraid, is that I heard Roland talk, okay, AI will help us and it will take over the repetitive work, but studies don't show that. Studies show that AI is in fact more focused on taking over the creative work and not the repetitive work. It's better at doing the creative work than the repetitive work, in fact. And this is different compared to previous automations, where typically the most boring stuff was taken over, which I think we all liked. But now, yeah, I like to do the creative part. I don't want to take this away from me. And a third one, where typically automation led to taking over job of the lowest paid workers, is today AI is impacting our highest paid workers. So, taking all this information into account, the question remains, will AI take our job or not? I'm first going to calm you down. You don't have to panic yet, because there are some general rules that still apply today, which can help us to make sure that we're not out of a job in the near future. Near future, I say. First one is called Jevons paradox. It's also an economist, and it talks about the fact that the moment that something becomes cheap and a commodity, for example, software development, it doesn't have to mean that the demand will go down. Instead, it typically goes up. For example, when the steam engines were announced and became more efficient, the coaling companies were afraid that they would become out of money because less coal was needed, but in fact, the other thing, the opposite happened, and even more coal was demanded. And a good example that we saw recently was with the announcement of, I don't know, this is the stock for NVIDIA, and it made a big drop at a certain moment in time. I don't know anyone what happened at that moment. Yeah, the moment the DeepSeek was announced, that claimed, and I have to say claimed, but in fact it was not completely correct, that they could train an AI model on a lot less power, and you see a big drop. Today it's already covered, so if you bought NVIDIA stocks at that moment in time, you did a good deal. And it's something that also was repeated by Satya Nadella from Microsoft. They said, okay, this is a good example. It doesn't, we all think, I think that AI will become a commodity, but it doesn't have to mean that it will be used less. Instead, we will even have more opportunities to grow and to work. Second law that I want to point out is what is called Amara law. And this talks about the fact that we typically overestimate what a technology can do today, although we need to take into account that we also underestimate what it can do in the long run. If you look at a specific technology, then today, regarding to the hype, in this case AI, we have maybe something like there, but if you look at the capabilities, yeah, we're not there yet. And if you look at the adoption, which even goes further, we still have a lot of things to do. Last thing, and a very important one, is we are a human-based society, meaning that although a lot of our jobs can be replaced by AI, for example, it's known for years that an AI is better than a radiologist, but still, the radiologist's job exists. There's also studies that show, for example, an AI bot can do it better as a doctor, but still a doctor exists. So it doesn't have to mean that because it can be replaced, that it will be replaced. And because the human fabric, our social economical system is really important for us, and we will not allow it to replace, otherwise we become a robotic organization. And that's something that we all fight against as a world organization. Okay, so these are some general things just to calm you down, to say probably there will be some impact, but not immediately, and maybe not that big as you expect. Then the question is, of course, because almost all of you in the room, with some people who don't want to confirm that they are developers, but most of you are, what is the impact on you? And first of all, before we can answer this question, we need to think about what in fact is the job of a developer. Is it coding? A little bit, only a little bit. Well, we all know that writing code is typically only a very small part of the job that we do. And we all get, I always get perfect requirements from my customers with perfectly written details and 100% clear acceptance criteria. So of course, AI can replace me because it's very clear what is expected. But we all know that in fact this is not the case. So I'm quite confident, and I repeat the message that Roland also did in the opening keynote, is that AI will certainly take some of our tasks away, but will not be out of a job soon. That being said, I do think there is some impact, and you will not like it. First thing, if you are a senior software engineer, any senior software engineers in the room, and I keep it quite fake, so it's up to you to decide if you are a senior or not. Senior in age can point up as well. It's okay. I have bad news for you. The bad news is it will not take away your job, but it will take away part of your salary. Because the reason that you are a senior developer is because you have, over the years, acquired some specific knowledge that makes you different from the other people in the room. And this is something that today we see that, yes, part of the skills you acquired over the years are no longer relevant. They are worth nothing. So the skills premium that you have today is impacted. And we need to be aware of this. We need to be aware of what is in fact our most important skill that's still relevant and focus on that one and maybe take less care of the other things. Because what we have seen, if you look at different studies regarding the AI usage, that it's typically not the best developers or the most senior people who had a big impact using AI, but it are effectively the low performers. People who are doing a really bad job or an average job. They are benefited most when using AI. So that's a risk. That's a risk for our future, not for our job in general, but certainly for the amount of money that we can acquire. Second thing, that maybe there are some people in the room that say, okay, but I'm a specialist, I know everything about Azure, or I know everything about front-end development, I'm really an expert in that. So it cannot be that I apply my very specific knowledge and skills. Any experts in the room who claims as an expert? Doesn't matter that much. Now the thing is with this, and the word single specialist is important. It's something I find very disturbing myself for a long time. I have been in software industry for 17 years. My original job was called an analyst-programmeur. And this meant I did an analysis part, the functional analysis, technical analysis. I did the design of the solution. I did the development. I did the testing. I did the deployment. And I fixed my own bugs. I did almost everything. And over the years, as teams started to grow, we saw that the job of a developer evolved to being only one specific skills. A lot of different roles around appeared, would maybe contribute to the end result, but maybe not. But it's a risk. To give you one specific example, before I created my own user interfaces, and for a reason I still don't understand, people asked me to stop doing that. I don't know why, but okay, they asked me, and instead I got a front-end developer as part of my team, and I cannot even say a front-end developer. It was a very specific. I'm an Angular developer, he claimed. Yeah, I threw him out because today I can use tools like OpenAI and just start asking, okay, generate me this user interface. It should look like this, and maybe provide it an image, and it does everything for me. So I don't need this specific skill anymore. So that's if you a one-trick pony, only knowing one very specific thing, you're in risk because AI can keep up with this kind of very specific work. And if it's Azure related, if it's front-end related, if it's not, is it security related, I do think that you are replaceable. So you will need more skills than only one thing that you're really good at to succeed. Now the last one, and in my opinion, the most concerning one, and I don't want to pinpoint at any specific junior. Maybe are there any juniors in the room? We are still juniors in some ways, so we can all raise our hands. And I'm pointing specifically to juniors, but maybe it applies to all of us. I think a lot of us, what we do, we only in fact need 2 keys or 3 keys on our keyboard. We need 1 key to go to Stack Overflow, 1 key to copy, and 1 key to paste, and that's how we do our job today. And with the introduction of AI, it even gets worse, because you don't have to leave your IDE anymore. You can just ask something, and it generates code, and you go on. As Roland was mentioning in his keynote, the fact that we are too much over-relying on AI is a big risk. And you also see claims on the internet that an AI today is like a junior developer. And if an IT manager reads this, okay, then that means that I don't need any junior developers anymore. Because an AI can do that, and an AI costs me $20, and a developer costs me, I don't know which amount, more. So we have kind of a knowledge paradox today, and I see this also in my teams, that the way that my senior people are using AI and compared to my junior people is completely different. Where the senior people, and it's not a generalization that I want to make here, is that they want to be the human in the loop, and they try to interact with AI, but they think and reflect and review, where junior developers are eager to just copy over and use it and don't always understand what the impact will be, which is not their fault. It's something human, and that you also see confirmed in different studies. And the studies make it even worse because the better that AI becomes, the more we are tempted to just take over what it proposes. So if we know that an AI hallucinates, then we know we're going to double check and review and only decide to use it if we're really sure that's a good idea. The moment that it's looking kind of okay, it becomes tempting to just take it over. And it's human, we all do that. And it's something that you not only see in software development, but also in other technologies or other professions where there's a lot of automation going on. For example, surgeons, it's a really big problem today to find a good junior surgeon because the things that typically a junior surgeon do is working together with a senior, where the senior is doing the more complex stuff during the operation, and the junior can do the more easy stuff. But today, the more easy stuff is done by robots during operations, so they don't need the junior anymore. But sooner or later, these senior surgeons will disappear, and the juniors will have to take over, but they don't have the experience. So if you look at medicine, for example, it's really an apprenticeship-based industry. And I think this also applies for our industry as well. So any hiring manager in the room, please don't stop hiring juniors. We'll need them in the future. This apprenticeship will really be important now, and for all these other sides will be big trouble, not today, but in 5 or maybe 10 years. That's really a big risk. So what now? What can we do? First thing, we have to understand that AI is weird. It's something called the AI frontier. Some things that we expected that it can do, it cannot do, and other things that we think it's quite impossible, it's really good at. So the only way that we can handle this is by making everyone part of R&D and saying, okay, here's the AI, go nuts. And this also means, if you are an IT manager, please don't try to control this. Don't do that. I see a lot of organizations asking, okay, we're going to first do a proof of concept, and then we'll write out an RFP, and we'll ask 5 or 6 vendors to really do a full study of what AI can do, and 7 months later they present the results, and it's no longer relevant at all. So that's a problem that I see happening, is IT tries to control this innovation. And this doesn't work for AI. Even worse, there's a reason I asked this question in the beginning, but I also see that a lot of my customers is that if I ask the IT department, are the people using AI? No, they're not allowed to use AI. If I ask the people, are using AI? Of course, I'm using on my phone and I'm just copying it over and taking a screenshot and I'm typing it and then I'm using it always. So you cannot stop it. People are doing secret task automation. Another question I got a lot is, okay, but what is the return on investment? Because it's really a big cost, this AI. Should we really do this? You can adapt the prompt, but just give you. I think it's an insane question. A GitHub Copilot license is $20. If you can save 1.1 minute a day, you have to earn it back. So why even asking this question? It's really stupid, and even then I have to make a whole business case, 500 slides explaining what the ROI is, and we'll have to do another proof of concept to really prove it works. So share this slide with your manager. That should be sufficient. Okay, next question then. When should I use AI? The answer is simple, always, unless there are legal reasons that you cannot use it, but even then there are ways to work around it, always. And if you ask me, which AI should I use? I don't care at all. All of them. Use any tool that you can find. If you have access to GitHub Copilot, use it. If you have access to ChatGPT, use that one. I'm a real big fan of Cursor, but anyone on the list is good. Try it out as much as you can. Now, let me inspire you a little bit, because I want to really show you, because this was just an introduction, in fact. Let me inspire you on how being a native developer today can look like. I hope that most of you today have at least some kind of Copilot available inside your IDE. And for example, is it GitHub Copilot, and that you're using the intelligence features, and behind the scenes today is already using AI. But yeah, you don't have to do anything extra, it's just got a lot smarter. that just works. So just the tap-tap-go that we had before, it still works. Another thing is we have any kind of chat interface that we use. We ask a question, we get some results, we copy it over, and that's typically the things that I see most developers already start doing today. You all agree? Is this something that you all do already? Yeah. Now, the problem that I see is that most developers stop there today, when in fact it's only the tip of the iceberg. I'm going to show you the way I am applying these techniques and tools today to make my job easier. First of all, a GPT is a general purpose, is a general generative pre-trained transformer, and in fact it's trained on a really broad data set. So it's really generic. And by providing it with a specific context about your way of working, your project, your documentation, your coding style, it can behave a lot better. So please use the prompt functionality that's available. If it's the JetBrains AI, if it's the custom instructions feature of Copilot, if it's the code-base indexing feature of Cursor, if it's the documentation ingestion of Cursor, which allows you to ingest documentation from a lot of freely available sources, but also can be linked to your own documentation, please do that. Because all this context will really help your Copilot to behave a lot better. If you follow a certain kind of conventions of coding style, if you're working just by saying I'm a C# developer, it all makes a difference. Just if you say I'm a senior C# developer, it even behaves better. If you say I'm a junior C# developer, it behaves worse. It sounds strange, but it has an effect. So really create this context and provide a lot of details. And you don't have to start from scratch. There are a lot of tools available. This one is not available yet publicly, but it will be available soon. So you can ask it to index your own code in Copilot. But if you look at some existing prompts that really can help, I take a look, for example, at the prompt library for Cursor. It's for every kind of job, there's already a lot of information available. Tweak it a little bit to your convention, your way of working, and it all behaves a lot better. And so these are just some examples. And that's a starting point. Second thing is what I typically do, I go to the design phase. So I take a requirement I got from a customer, a user story, or whatever, of a document that they provided me, and I fed it a specific prompt. Not a specific prompt to do something, but a specific prompt to discuss. So I just did an example, and you don't have to take a picture because I will share the slides at the end. And in this case, what I typically like to do, I like Aider, but you don't have to use that tool, it can be a different one as well, because the Aider has an architect mode. And architect mode is really meant to start, in fact, a kind of pair programming design session with you, where it's asking questions and how do you do it, and what are edge cases, and so on. And all this information, it will be used to, in the end, what I typically try to create is kind of a design document, so a specification file with every details in it. Once I have that document, I asked the GPT, doesn't matter which one, to also generate some diagrams, because it can really be helpful to not only understand, okay, this is how you look at it, but yeah, draw me out the sequence flow, or maybe the different parts, generate me a C4 model of any other kind of model that you prefer, just to give also a visual understanding on what it will be, and iterate on that as well. And this information also, again, becomes part of the specification and can be fed inside to your AI and provides better results afterwards. I also like to immediately, because we all build in a secure by design way, I'm using tools like StrideGPT, which you can then fed your specification file, your diagrams, and say, okay, what are possible vulnerabilities, what are things I need to take into account, what are things I should be careful for, and it will do the full threat modeling of your application, spitting out all the details of all the actions you need to take. Next thing is, depending on the type of application I want to build, if it's a really small one, then I typically like to use prototyping tools like Bolt, which also has a do-it-yourself version if you don't want to use an online application. You can run this fully locally to generate me a first blueprint of an application, or a V0 is also one I like, and you get a starting point to already have a lot of information and a good head start. But it's only the beginning, and typically for more complex applications, I take a different approach, and then I ask it to take the specification file, take these diagrams, take this information I got from the threat modeling, and everything, and create use a second prompt to generate me a large list of tasks and prompts that I can use. So it will create a full action plan, And typically I use the reasoning models for that. That is the DeepSeek or the O3 version of Cloud 3.7, which is really, really nice, I think. These are all really, really great to do this kind of stuff. And because they have kind of a deep thinking mode where they start to understand what's going on and generate a full task plan on what should be done. As I mentioned, I'm really bad at user interfaces, so if I find a user interface I like, I also fed it to the system to saying, okay, based on this visual, generate me a user interface, or I use OpenAI, that's what I showed you already before. What I also then typically do the moment I'm start to use this prompt is then I arrive in the chop mode, the chat-oriented programming, where I enter the prompt, it does the AI does something, I edit it again, I change it a little bit, and I tweak it until I think it's what I expect, and then I move on to the validation and the testing. First tool I like to use is CodeScene, which is also a tool for code quality, but it has an automation mode where it can do auto-refactor. So I typically ask it, okay, look at this code, what can be done better? And it tries to auto-refactor it for me, so it already improves it. I also like to do SWA agent, which allows you to interact with your machine, so it can be used to do test automation. And I especially use it for the threat modeling again, and for really do kind of penetration testing, where you can use Enigma, which is built on top of the agent. So in fact, a lot of things that are possible. And the last one, of course, documentation. Documentation is really important, but we never like to do it. There are a lot of ways. For example, this one is in Devin, where you can take some information and say, okay, this is really relevant for the future. I can put it inside a knowledge base. It becomes part of a RAG in an embedding database, where it can be used later on to query it. And one I've used myself, the site itself is not relevant, although it's a really interesting site, but the way it's created is fully automated based on prompts. This is full documentation website with examples and so on, is fully based on prompts, and this is available on GitHub, and I use that one to create my own documentation website as well. So I really like the example that's given here. And then if you have all this information, you can use tools like OutHub, which allows you to create one big context that can be fed in again inside your AI, and then you're back in the beginning and you can do this again. And typically this cycle, if I do this, it takes about 2 to 4 hours. That's typically the time I take to do this. And that's what you can do today. So be aware, what I'm showing today is first of all what's now possible, and take into account this is in fact the worst AI you ever get. It will only get better. So then if we try to take this information into account and also try to predict a little bit the future, and I know it's hard, but we can try. First of all, there are some studies that say, okay, the way software will be built will be, there will still be, first of all, on the short term, there will always be a human in the loop. It was also mentioned in the keynote, but our role remains important. What you don't see here, you don't see an analyst, you don't see a tester, you don't see a designer. What they're expecting is you all, as software engineers, will have to take into account a broader set of skills, and you will be the one who connect all the dots. That will be your job in the future. Of course, if you look further ahead, now it's all agents everywhere. We are already seeing agents that take over specific tasks, but also see an evolution regarding that agents are taking over end-to-end processes. All the tips that I've shown you today, the contextualize, the design, the build, the test, and so on, there are agents already. An example is MetaGPT, which where an agent can take on different roles, and you have multiple agents, and you can kind of use an agentic software company where all the roles are done by agents. But yeah, who knows will it succeed or not, but these are things that I work on. Second thing is, what I also see is that if you have ever read this book about thinking fast and slow, that talks about how our brain is working, and we have two types of systems in our brain. It's a reptile brain, which is system 1, and we have more our human brain, which is system 2. And the claim is today that in AI context, they're claiming we're today at system 1.5. AIs can only do kind of reasoning, but they're not a system 2 yet. And the claim, I don't know if it will be true or not, is that the moment we arrive at system 2 thinking for AI, then we have what's called an AGI an artificial general intelligence, and then it will take over the world and we all die and so on. But it's for the long run. No? What certainly you're hearing more and more is maybe this programming language is no longer relevant, and the only language that we need to understand is our own language. And we use a human language to start define our specifications, and everything else will be derived from that. So where today, in fact, the real specification is our code. So if you ask what is, in fact, how a system is built, don't look at the documentation, look at the code. Maybe there will be a future where we can look at the specification, and then we know how the system is built. Maybe, maybe not. What this could mean is that our jobs evolve from being a software developer that we become a software manager. They all become managers. Bigger cars, bigger checks, perfect. But it's certainly a possibility, and it's also mentioned in the keynote. As you're already seeing, is that, the agent will be doing more and more of the work, and we will be the one controlling the work and maybe steering it a little bit, so we become a manager of one or more agents. What I'm also seeing, or that maybe can be happen in the future, is that we'll get to a lot smaller teams. Today we have typically kind of big teams, although they are limited to the amount of knowledge that you can get in the head of a few people. But if you have an AI, there's maybe a lot broader context that we can capture, and we only need a few people in combination with AI to do the job in the future. And this could mean, for example, that where we had today a 2-week sprint, that in the near future maybe we have a 1-day sprint. In the example I showed you, typically the cycle I take here is it's about 4 hours, and I'm typically exhausted, so the rest of the day I'm just Googling out and what I can do next with AI. But in half a day I can do already a lot. But I certainly think there's a future where, we'll do a sprint in 1 day. Okay, I have a few minutes left, so I'm gonna take one extra chapter in to end. One question I got a lot is regarding productivity impact. There are a lot of different numbers appearing all around, and one of the original papers that was used in the beginning was done by Microsoft together with MIT, and I think it's Accenture, and that was used to get some numbers, and I think in that paper they claimed to have an increase of productivity of 26%. You get some numbers, for example, from GitHub, but of course they are claiming that is a lot more. They're talking about 55% productivity increase. I was reading a study from ThoughtWorks again, and they're talking about something more realistic, which I think I agree with better today, is 10-15%. So they all agree that in fact there is a certain productivity win of AI. Take this into account together with the calculation I did, where if you win only 1.1 minutes, you already earn it back, so there's no reason to not start using it. But that being said, I was also looking at Dora. I don't know everyone knows Dora. I've heard about it. It's a DevOps report. It's published every year for I don't know how many years already. And this time there was a specific chapter about AI as well. So they typically ask a lot of questions about different companies in the world and software engineers about different things and how they are productive and what they're focusing on. And this time it was really a big focus on AI. And what you saw there is in fact that instead of, and it's quite small to read, but they're saying instead of having a productivity win with AI, they saw a productivity decrease. And the throughput went down with 1.5%, and the stability, the quality of the result, got down with 7.2%. So what in fact is going on here? And I was further reading in the article, and I hope it hangs for some reason. I'll hope. Oh, I'm going too fast now. It was also what I noticed in the same article of ThoughtWorks. They say, okay, we see an increase in bug rate. So something else is going on here. And I found some numbers and found an example that really explains it quite visually. The impact of using these tools is that we start arriving at bigger pull request sizes. So people are creating a lot of code. Before you got, I hope you get a pull request with 10 lines of code to review, not 2,000 lines of code. But you see that the pull request size starts to increase a lot. This also means that our review time, certainly if you're a senior engineer, you spend a lot of time reviewing someone else's code, yeah, it also goes up. And what happens, this is a confession I'm making here. If I get a 10 lines pull requests, I review it quite thoroughly. If I get 2,000 lines pull requests on a Friday afternoon when it's sunny outside and I want to grab a beer, I just say approve. And I think we all do. And of course, what is the result? Yeah, that the quality goes down. And it's something that you also see in different ways. For example, an example I found online of a team that's adopting Cursor, an AI-enabled IDE, and they saw a bottleneck appear somewhere else, in this case, the user experience part. And in fact, this is quite well explained in the theory of constraints idea, is that, they say it quite nicely, is that although we do local optimizations, so although we can optimize specific tasks, the development goes faster, the documentation goes faster, it doesn't have to mean that the end-to-end result is positive. Because there are reasons why our system fights back, and only if we, and it's because we are optimizing specific parts that we also start seeing the bottlenecks. And so we also have to start tackling these bottlenecks to become fully productive in the end. Now, a few things to conclude or to take away with this session. First of all, if you ask today, and it's not an approved answer yet, but if you ask me, is AI GPT? I think the answer is yes. I really assume that AI will really have a big impact, not only on us as software developers, but on our society as a whole. There will certainly be an impact. Does this mean that no matter which profession you are in, that you will have a job in the future? I think we all need to be aware there is no such a thing as job security. But I don't think that has to be a problem, but I do believe that we all can have career security, meaning that if we focus on expanding our knowledge and staying away from the fear that was mentioned during the key opening, and we start to keep learning, keep working on interesting projects, and keep working with people we can learn from, I think we all have a nice job in the future. And please do experiment as much as possible. Download all these tools, play with them. Play with them at home, play with them at work. Don't ask your boss, not necessary, we all do it. But experiment, experiment, experiment. Also, if today you're a single specialist knowing one specific skill, please start to broaden your knowledge. Make sure that you become a specializing generalist where you have a broad knowledge and maybe expertise in multiple domains. It will really be necessary to be relevant in the future. So in my opinion, we are not out of a job yet, because although I'm showing you some nice things that we can do, what I also experienced is that, if you're really building complex business applications, this is something that an AI cannot solve for you. This is also the thinking part that's necessary, the careful consideration about the design, doing all the trade-offs. AI can help us there, but it's still our job to do that. And this is something that will not be replaced easily in the future. And I want to end with a quote from my favorite philosopher, as I always like, which is B.A. Baracus. AI is a tool, and a fool with a tool is still a fool. Thank you. If you want to download my slides, I will put them on my GitHub later today, and this is this link. I also would really like it if you review my presentation and give me some feedback. It will really help me to improve this presentation. And if you have any questions, feel free to come to me. I also have a next slide after this one with a lot of different tools that I'm using today, so you can use that one as well to get inspired on what's possible and what's not. I hope you all enjoyed my presentation and have fun at the rest of the conference.